On this topic we will be discussing the second phase provided in their training regulation TR. Every learner shall complete the 56 hours for all the 9 modules. Our topic of discussion is focused on the operation of welding machine, its function and definition. The shielded metal arc welding SMAW-NC2 qualification consists of competencies that a person must achieve to weld carbon steel plate and pipe components as specified by layouts, blueprints, diagrams, work order, welding procedure or oral instructions using shielded metal arc welding equipment. This qualification conforms with American Welding Society-AWS D1.1 Structural Welding Code, American Society of Mechanical Engineers, ASME, N number 9 in the Welding Code Boiler and Pressure Vessel Code, American Petroleum Institute, API, 1104 Code for Gas and Oil Pipeline Facilities, and International Standards Organization, ISO, 9606-1 Qualification of Welders for Steel. Arc welding is a type of welding process using an electric arc to create heat to melt and join metals. A power supply creates an electric arc between a consumable or non-consumable electrode in the base material using either direct, DC, or alternating, AC, currents. Welding is a fabrication process that joins materials, usually metals or thermoplastics, by using high heat to melt the parts together and allowing them to cool, causing fusion. Welding is distinct from lower temperature metal joining techniques such as brazing and soldering, which do not melt the base metal. In addition to melting the base metal, a filler material is typically added to the joint to form a pool of molten material, the weld pool, that cools to form the joint that, based on weld configuration, flux, full penetration, fillet, etc., can be stronger than the base material, parent metal. Pressure may also be used in conjunction with heat or by itself to produce a weld. Welding also requires a form of shield to protect the filler metals or melted metals from being contaminated or oxidized. Until the end of the 19th century, the only welding process was forge welding, which blacksmiths had used for millennia to join iron and steel by heating and hammering. Arc welding and oxy-fuel welding were among the first processes to develop late in the century, and electric resistance welding followed soon after. Welding technology advanced quickly during the early 20th century as world wars drove the demand for reliable and inexpensive joining methods. Following the wars, several modern welding techniques were developed, including manual methods like shielded metal arc welding, now one of the most popular welding methods, as well as semi-automatic and automatic processes such as gas metal arc welding, submerged arc welding, flux core arc welding and electroslag welding. Developments continued with the invention of laser beam welding, electron beam welding, magnetic pulse welding, and friction stir welding in the latter half of the century. Today, as the science continues to advance, robot welding is commonplace in industrial settings, and researchers continue to develop new welding methods and gain greater understanding of weld quality. The development of coated electrodes did not occur until the early 1900s when the Gelberg process was invented in Sweden and the quasi-arc method was introduced in the UK. It is worth noting that coated electrodes were slow to be adopted because of their high cost. However, it was inevitable that as the demand for sound welds grew, manual metal arc became synonymous with coated electrodes. When an arc is struck between the metal rod, electrode, and the workpiece, both the rod and workpiece surface melt to form the weld pool of molten metal. Simultaneous melting of the flux coating on the rod will form gas and slag which protects the weld pool from the surrounding atmosphere. The slag will solidify and cool and must be chipped off the weld bead once the weld run is complete, or before the next 12 parts is deposited. The process allows only short lengths of weld to be produced before a new electrode needs to be inserted in the welding electrode holder. Weld penetration is low and the quality of the finished weld deposit is highly dependent on the skill of the welder. Types of flux, Electrodes. To strike an arc between the electrode and base metal, such as carbon steel, and to produce a good quality weld, a stick welder must ensure that their welding machines are fitted with suitable electrodes. Arc stability, depth of penetration, metal deposition rate and positional capability are greatly influenced by the chemical composition of the flux coating on the electrode. Electrodes can be divided into three main groups: cellulosic, rutile, basic. Cellulosic electrodes contain a high proportion of cellulose in the coating and are characterized by a deeply penetrating arc and a rapid burn-off rate, giving high welding speeds. Weld deposit can be coarse and with fluid slag, deslagging can be difficult. These electrodes are easy to use in any position and are noted for their use in the stovepipe welding technique. Features: deep penetration in all positions. Suitability for vertical down welding. Reasonably good mechanical properties. High level of hydrogen generated. Risk of cracking in the heat affected zone, HAZ. Rutile electrodes contain a high proportion of titanium oxide, rutile, in the coating. Titanium oxide promotes easy arc ignition, smooth arc operation and low spatter. These electrodes are general-purpose electrodes with good welding properties. They can be used with AC and DC power sources and in all positions. The electrodes are especially suitable for welding fillet joints in the horizontal, vertical, HV position. Features: moderate weld metal mechanical properties, such as tensile strength. Good bead profile produced through the viscous slag. Positional welding possible with a fluid slag containing fluoride. Easily removable slag. Basic electrodes contain a high proportion of calcium carbonate, limestone, and calcium fluoride, fluorspar, in the coating. This makes their slag coating more fluid than rutile coatings. This is also fast freezing, which assists welding in the vertical and overhead position. These electrodes are used for welding medium and heavy section fabrications where higher weld quality, good mechanical properties and resistance to cracking, due to high restraint, are required. Features: low hydrogen weld metal. Requires high welding currents, speeds. Poor bead profile, convex and coarse surface profile. Slag removal difficult. Metal powder electrodes contain an addition of metal powder to the flux coating to increase the maximum permissible welding current level. Thus, for a given electrode size, the metal deposition rate and efficiency, percentage of the metal deposited, are increased compared with an electrode containing no iron powder in the coating. The slag is normally easily removed. Iron powder electrodes are mainly used in the flat and HV positions to take advantage of the higher deposition rate. Efficiencies as high as 130 to 140% can be achieved for rutile and basic electrodes without marked deterioration of the arcing characteristics, but the arc tends to be less forceful, which reduces bead penetration. Power source. Electrodes can be operated with AC and DC power supplies. Not all DC electrodes can be operated on AC power sources, however AC electrodes may be used on either AC or DC. Welding current. Welding current level is determined by the size of electrode. The normal operating range and current are recommended by manufacturers. Typical operating ranges for a selection of electrode sizes are illustrated in the table. As a rule of thumb, when selecting a suitable current level, an electrode will require about 48 per millimeter diameter. Therefore, the preferred current level for a 4 mm diameter electrode would be 160 A, but the acceptable operating range is 140 to 180 A. Here at Global Tech Manpower Institute training provider are using the transistor, inverter, welding machine technology. The insulated gate bipolar transistor, also called an IGBT for short, is something of a cross between a conventional bipolar junction transistor, BJT, and a field effect transistor, MOSFET, making it ideal as a semiconductor switching device. Since it is designed to turn on and off rapidly, the IGBT can synthesize complex waveforms with pulse width modulation and low-pass filters, so it is also used in switching amplifiers in sound systems and industrial control systems. In switching applications, modern devices feature pulse repetition rates well into the ultrasonic range, frequencies which are at least 10 times the highest audio frequency handled by the device when used as an analog audio amplifier. As of 2010, the IGBT is the second most widely used power transistor. This IGBT welding machine is now enabling very small and comparatively low-weight power sources to be produced. These power sources are finding increasing use for site welding, where they can be readily transported from job to job, as they are electronically controlled. Global Tech Manpower Institute Training School offers an appreciation course on MMA welding. This includes theory and practical sessions, with approximately 75% demonstrations and hands-on sessions, appreciation of the welding processes and fundamental basic knowledge. Health and safety, setting up equipment, welding process parameters, process-related defects and how to avoid them, welding consumables. Welder or operator always watch for duty cycles. Indicator of the welding machine are low compared with semi-automatic and automatic processes. This makes the cost per pound of deposited weld metal high with stick welding. Deposition rates are generally lower than for other welding processes. The process is considered to be manual as it is not easily mechanized. Stick welding is not suitable for reactive metals such as titanium, zirconium, tantalum, and columbium because the shielding does not prevent oxygen contamination of the weld. Stick welding, also known as shielded metal arc welding, SMAW, or covered electrode, the most widely used of the various arc welding processes, utilizes a fixed-length electrode and an electric power source to join a variety of different metals. The core of the covered electrode consists of a solid metal rod that is surrounded by a covering of mineral compounds and metal powders mixed with a binding agent to help them adhere to the surface of the electrode. The core rod conducts electric current to the arc and provides filler metal for the joint. The sizes and types of electrodes for stick welding define the arc voltage requirements, within the overall range of 16 to 40 volts, and the amperage requirements, within the overall range of 20 to 550 amps. The current may be either alternating or direct depending on the electrode used, but the power source must be able to control the level of current within a reasonable range to respond to the complex variables of the welding process itself. The primary functions of the electrode covering are to provide arc stability and to shield molten metal from the atmosphere with gases created as the coating decomposes from the heat of the arc. This shielding controls the mechanical properties, chemical composition, and metallurgical structure of the weld metal, as well as the arc characteristics of the electrode. The composition of the electrode covering varies according to the type of electrode. Why use stick welding? Stick welding is an extremely versatile process with respect to location and environment of the operation. Welding can be done inside, outside, on a production line, a ship, a bridge, an oil refinery, a cross-country pipeline, or similar types of locations. Gas and water hoses are not needed, and welding cables extend significantly beyond the power source. In remote areas, gasoline or diesel-powered units can be used. Equipment is relatively simple, inexpensive and portable. Auxiliary gas shielding or granular flux are not required. The process is less sensitive to wind and draft than gas-shielded arc welding processes.